All right, let's just start on some of the stuff that we've been working on. So let me give you a couple of updates about some of the things first. First of all, sorry that I was away for a couple of days or more than a couple of days. I was in an internal event somewhere else, not here, and I was in all-day meetings, so I'm a little bit behind on code reviews, but I will get to them hopefully today. And if there is anything left for 112, please let me know. I will be happy to take a look and work with you guys to get them for 112. We only have like several more days. Code freeze is on September 4th. So there is only several days left, and we need to work on any PRs that needs review or needs more work to prepare them for 112. One of the things that we've been working on was performance improvement, particularly an area which needed a lot of work was interpod affinity and anti-affinity. If you remember from like a few months ago, we had this problem that affinity and anti-affinity was 1,000 times slower than many of other predicates. And then, like, I don't know, a couple months ago or so, I added an optimization which improved our performance by 20x. And recently, I worked with a couple of folks in the community to implement another optimization that has improved performance by another 4 to 6x. So overall, we are seeing more than 100x performance improvement given these two optimizations that we've done for the affinity. So which brings us to about 10x slower compared to other predicates. And as you know, some of our other predicates are really, really fast. And being 10x slower for such a complex predicate is not bad at all. And I'm very happy to see that this has happened. You may remember that the affinity and anti-affinity performance was so bad that we had to go and update our public Kubernetes documents and ask people basically not to use these predicates if they have a cluster which is like more than a couple hundred nodes. And now with these improvements, we are hoping that we can remove such constraints and we can make these predicates usable by everybody in much larger clusters. That's one of the updates. So we are working on several things. Since Rob is here, one of the work that we've been thinking about and we wanted to do is descheduler and promoting descheduler to a standard component in Kubernetes. Looks like since we're not on the same page with respect to promoting it or graduating it from incubator, it's unlikely that we can actually make it a standard component of Kubernetes in 112. But there was some discussion about how to actually use the scheduler in the future, basically making it a part of the scheduler and maybe running it as another thread of the scheduler versus running it as a separate component. And my own vote was to basically have a separate component, and I had several reasons for it, mostly around the reliability. Basically, I wanted to make sure that the scheduler is not going to interfere with the scheduler. For example, if there is a bug in the scheduler causing a crash or something, scheduler is not going to get affected. When you're in the same process, management of it is going to become a little harder. It's also more flexible if it's a separate component. It allows us to run it somewhere else. It allows us to not run it at all. Maybe some of the users don't want to run it ever. So those guys have this opportunity. Of course, it could be configurable so that, if it was one single component, it could be configurable and users could disable it. But configuring some of the components in some of the bigger deployments of Kubernetes, like for example in GKE and some of the other similar hosted Kubernetes, is not possible by users. So as a result, users are stuck with whatever their cloud provider or service provider has chosen for them. If it's a separate component and we leave it up to the user to want to run it or make it more configurable by the interfaces and all whatnot, makes it a little bit easier to manage. It's also more scalable because we don't need to run scheduler and descheduler on the same node anymore. They can be separated and run in multiple nodes. One of them may run on the master node, the other one might run in any other cluster node. So there were some of these reasons that I personally thought having a separate component would be better. Rob is here today. If Ravi, you have anything more to add or you have different opinion, please tell us. Other folks, if they have any opinion about this, please say that today.
Yeah, so as I've mentioned, I think even in the email thread, I have mentioned that I believe that it has to be a separate component because you could use it in autoscaler or some other component. So the autoscaler calls descheduler so that there is a balancing of nodes happens if a new node gets added in the cluster. So there are advantages of running it outside of scheduler. And the other thing is the implementation also becomes a bit difficult because there is nothing like dynamically loading components in Go. Like they have something similar to that from Go 1.7 called plugins. I was doing some research about it, but rendering this and then dynamically loading or equivalent of dynamically loading this binary might be implementation wise difficult. And then descheduler could be used for other aspects as well. So if we limit it to the core scheduler, some of the functionalities that we have in our mind for the roadmap, we may have to take that out. So because of that, I'm also in favor of having it separately instead of putting it in scheduler.
Okay, yeah, thanks. A quick thing about those plugins, those Go plugins. For the scheduling framework, I was also thinking about maybe using some of those some of those Go plugins. But Brian Grant told me that there are multiple issues with those Go plugins, and they are not great for implementation. There are some details about it, but I don't want to take the time of the team.
Yeah, so we just have to exec that, like using os.exec or something like that. We have to call that binary, which is not
yeah,
many.
and I guess there are some version SKU issues as well, which makes using them a little hard. So
okay,
yeah, there are more than one issue. Yeah, is there any other objection, comments about any of this from other folks who are present in the meeting?
I had a question about one of the comments that was made was that because users can't control the default scheduler in installations like AWS or GKE rather, that we shouldn't have it be a part of the main scheduler because then they couldn't configure it and would have to be using whatever GKE chooses for them. Is that going to affect us in the future? For example, with the scheduler framework, we're talking about breaking out components into plugins and saying that these plugins are configurable, which ones you run and what their weights are and so on and so forth. So it seems to me that like, if we say that people can't control which scheduler they use, that also means that they can't use scheduler framework or at least change the settings of it. And therefore maybe can't even add plugins like we are saying that they can. So what are we thinking about that, I guess?
Yeah, that's a valid point. Actually, even without the scheduling framework, with our current scheduler, we have a configuration that you can actually disable some of the predicates and priority functions, very similar to the idea of the scheduling framework where you can add or remove some of the plugins. But in GKE, users don't have those kind of controls. There are ways maybe that GKE, for example, can implement some other UI that that allows users to change those configurations, but those UIs are not in place. Those configurations are not in place. So currently users cannot really change anything. It's not impossible to think that we can build some sort of a mechanism, for example, I don't know, in Google Console to allow the users to change some of these weights or add or remove some of these plugins. But there is also the supportability aspect of the problem. So because of that, there is a lot of objections about allowing users to change their scheduler configuration. So they some people think that users may not know exactly what they are doing, and they may basically shoot themselves in the foot. So there are some of these issues, and then SRE may also not be aware of these, like at least at first glance may not be aware that their scheduler is different from the default scheduler, and that's why their cluster is behaving differently. So providing support could become more difficult. So there are some of these concerns that should be figured out. But anyway, we are not always optimizing for some of these hosted environments, and this particular concern was one of the few concerns that we had about like putting the two components together. It was not the only one.
Yeah, no, of course. I'm just fearful of using the excuse that like, if we build a feature, they'll use it or something like that to say that we shouldn't. And if we're going to provide this functionality, like it seems like if I run on, like I want to use GKE too, I should be able to use it too.
This is slightly different than just changing the behavior of scheduler itself. This is more than just the scheduler itself. These schedulers, for example, can help you balance your cluster better and things of that sort. So it's slightly different, and because of that, some users may actually want to run these schedulers separately.
Okay.
Yeah. All right. Is there any other comments or questions? Okay. One more update that I have for you is that probably we won't be able to move equivalence cache to beta. You're seeing some issues, and we are not 100% sure about the current implementation. So we are still exploring some of the options here, and we are very close to the code freeze. So equivalence cache, which is a mechanism for us to improve scheduler's performance further, it's probably not going to make it to 112. I mean, it's already there. It's not going to make it as a beta to 112. Pod scheduling policies is being worked on. Yassine has updated the document, and I think we are almost there. The final comment from two of our big engineers, Brian Grant and Tim Hawking, both were saying that we should not build this as a first. I don't know how to call it basically, but basically we shouldn't make it like a V1 API. We should go with CRD in the beginning, and then in the next level or next stage, after we get some feedback from users, we will promote this to like a standard API of Kubernetes. And that's actually a valid point and a good comment. We are probably going to do that. We are going to start working on the implementation, hopefully for 1.13. And we will hopefully see it in 1.13, at least the alpha version of scheduling policies in 1.13.
So Bobby, are you referring to the scheduling policy? Right now, we are using a config JSON file to configure which predicate, which priority we can control, right?
I'm not talking about those like scheduler configuration. This is like pod scheduling policies. The scheduling policies is more than that. So these are similar to like security policies, or if you like RBAC kind of thing. So it basically tells users what kind of scheduling requirements they can put on their pods. Today, we don't have any of such policies. For example, I can, imagine a multi-tenant cluster. I can go and put some anti-affinity rules on my pod, and if I get lucky and my pod is scheduled, I can have anti-affinity to everything else in the zone. In that case, if my pod is scheduled, nobody else can schedule any pods in that zone, right? So admin may want to prevent some scenarios like this. Or another example is that some customers go and taint their more expensive nodes, for example, nodes with GPUs with a special taint, so that pods that don't need those kind of expensive resources never land on those nodes. But nothing is there to prevent users from putting the tolerations for those taints on their pods. So as a user in a multi-tenant cluster, I may as well go and put a toleration for those taints and put my pods that don't need those expensive resources on the nodes that have those expensive resources. So there are some of these concerns. We're trying to address those by pod scheduling policies.
Yeah, I got it. Thank you.
Yeah, sure.
But I think that the whole the premise is the fact that you centralize your policy, your scheduling policies in one place, as opposed to scattered all over the the part specs and all that. I mean, similarly, the security is the same way. Though. You centralize it, yeah, for auditing.
We didn't actually have even the scattered version of it. So we didn't have any policies really to prevent users from putting some of these scheduling requirements on the pods that would affect other users in the cluster.
Well, I mean, currently your policies are essentially the pod specs. You define everything at the pod level. Okay, this pod has the entire affinity with this or whatever. As opposed to that, you define it in one central place where the admin.
No. This is slightly different than just putting those. So in a pod spec, you put the scheduling requirements. So basically, you say, for example, I want to have anti-affinity, or I want to have toleration, things like that. But the scheduling policies actually specifies who can put what kind of affinity, or who can put what kind of
okay.
Stuff like that. So it's actually policies similar to like
more like a RBAC kind of thing. Okay.
Yeah, exactly.
Yeah.
Okay. All right. So I have one more update for. Well, actually, I don't know if Harry is here. I wanted to get an update from Harry about like image locality priority. That priority function is already there, but we haven't been able to move it to. I guess we have been able to move it to beta, but we haven't been able to get the test end-to-end test working because we had some issues with uploading the images to GCRI, or I don't know the status of that, whether it's done or not. But I will follow up with Harry separately. All right. So yeah, Wei, you are here. What is the status of scheduling pods by the default scheduler?
There are two major issues. One is the update the flag in the queue features.go, and that caused some unit tests and integration tests fail. So yeah, thanks for Ravi on pushing one of the PRs to get those resolved. I think the changes are fine, but we need, because the approval are only Janet and Mike Dennis. It seems we can't get hold of them to get approval for that.
Is that the only blocker right now? I can actually go to there. I mean, I can.
Yeah, that is one blocker. The other blocker is that, let me give you the issue number. So that.
I think it's related to the performance when taint node by conditions is enabled in large clusters like 5K nodes and above. There is an issue created by scalability that some of the nodes are not at all coming up, and some of the nodes are taking a lot of time for the taint to be applied.
I see. So we have scalability issues in large clusters.
That is right, and that's.
That is not scheduled daemon set. That is 10 node by condition.
Yeah, that's what I told. Oh, I'm sorry. This is specific only to.
Yeah.
Okay, sorry. My bad.
Yeah. So where you said that there are two issues. One was updating a flat causes test failure. What was the other problem?
The other one is that for some scenarios we didn't give the taint properly and didn't give the toleration properly.
Yeah, I remember that problem, but I think the PR was out, isn't it? I thought it's merged, right?
Still we need McDaniels and Janet to approve.
Okay. So, but the PRs are out. We just need them to be approved, right?
I think the PRs have been approved back and forth several rounds.
Okay.
So, yeah, remember last week I mentioned another PR raised by me, but that PR can be closed because the changes has been contained by Klaus' PR. This one is 66526. So for this one and the test failures one, then we're good for this feature.
Okay, thanks.
Yeah.
So both have PRs. All right, let's see. That's, I guess, all the stuff. if there is any other question, comments, or updates from you folks, please share them with us now. Deepak, how are things on the Poseidon side?
Yeah. So I think I wanted to give update. So in the scheduling SIG test we ran, so there are total 41 tests. Out of that, 30 passed, and 11 of them failed. 2 of them were related to the environment, NVIDIA GPU, and there was another one called the resource quota thing. So we didn't. So even the default scheduler was failing for that as well. So we didn't really bother looking into that. Sure. And 4 of them are related to events. Essentially, if your scheduler cannot ever schedule the pod because of the label, it's a scheduler pod has a label which doesn't exist in any node, so it's never going to get scheduled. So it sends out an event, it seems. You see. So yeah. So the test checks for that if the event has been sent and all that. So.
Oh, I think I see. So I guess that's the API. So basically, when we update the status of the node, we get an event. Is that?
No. What happens is, so the scheduler, so the node comes in, says, I need the node affinity for a node which has a label A, okay? But then there's no node in the cluster which has a label A. So this part is never going to get scheduled, basically.
Right. Okay? But you're waiting for an event.
So the test case, essentially, there are 4 failures which are essentially related to events. So essentially, it's checking for events that, these, so there were 3 of these kind of negative tests. And then because we don't have an event thing in place, so it fails because we're not sending out events. And then for all the successful pods also, it sends out 1 event as well, it seems.
I see. So basically, if the pod is unschedulable, we update the status of the pod and reflect that the reasons that it's unschedulable. And then when we update the status of a pod, we get events for the fact that pod is unschedulable. Probably that's why you are not seeing the events. Basically, maybe you are not updating the status of a pod.
So you're saying the event automatically gets sent out the moment you update the status?
Yeah, if you have the API server sends you the events.
Okay. So I think we looked at the code and we explicitly saw that event is being sent. So the status is set, and at the same time, event is also sent out somewhere. To some events.
Yeah, like in scheduler code, we have some events being generated. Like we have an event recorder and all that. I do not know which event you are referring to, but yes, we have some events.
Yeah, some of them actually. So the 4 failures. So, and even for the successful pods also, it sends out an event.
So we have 2 completely different categories that both are called events. One is informer events. Informer events are the events that you get for the updates of any object in like Kubernetes, like API server sends out those events. I'm not so sure if you're talking about informer events. Maybe.
Well, I think we don't know what the difference is. The tests are failing because of that. The E2E tests are failing. So I think that was one. So we're getting to the bottom of it, and then so this is more like not a scheduler issue, but it's more.
This is actually something. And the surrounding.
So the 2 scheduler related issues. One was the ephemeral storage, and we don't check for that right now. See, the ephemeral storage, we only check for CPU memory. We don't check for if there's enough ephemeral storage. So that's one thing. We're going to fix that. I think. And then the last one is the max pod thing. So currently the max pod logic, which we have on a node, is only considers the pod scheduled by firmament. So we are going to do the add informers to all other pods, for all of the pods scheduled by. So that should take care of it as well. Okay. And remember the discussion we had last time as well. So, for example, some of the pods are scheduled by the default scheduler or some other daemon set scheduler or whatever. So we need to, when we do the max pod per node logic, we need to account for those pods as well. Basically.
I see.
Yeah.
So and then, given your progress, do you see that we could possibly have an alpha version of Poseidon in the next release or next?
Well, so there's another problem which we are looking at is the PV thing actually, which is a storage SIG. A lot of tests are failing because we don't have a predicate for the PV thing. So once that's done, And we have this, so it's essentially the coexistence of Firmament or Poseidon with default scheduler. There are two problems. One is we are breaking things, for example, the one I just enumerated, these cases. And the other one is the default scheduler. So we need to kind of account for, the things which are the parts which are scheduled by default scheduler or some other scheduler. So once we fix that, we don't see any. I mean, the functionality wise, it's all in there now, pretty much.
Okay. That's great. That's great news. So I guess maybe the latter problem is whole easy. I don't know how how you've implemented things, so I cannot really say with confidence. But the latter problem seems a little easier. I guess the PV issue might be slightly more complex because PV is more than just a predicate. Currently, in the default scheduler, a pod that requires PV goes through, usually if the required persistent volume is not mounted to a node, it goes through like 2 cycles of scheduling. In the first cycle, we go and find a node for the pod, and the PV controller starts binding the volume to that node. And then in the second round, now that the volume exists on a particular node, that node will become the only place for the pod that can be.
Is that the dynamic load local volume provisioning thing, the one that went in 1.11? Is that? It's
not 1.11. It's actually started, I guess, in 1.9. But yes, it's dynamic volume provisioning.
Yeah, but what I was told that code is not merged yet. So you're saying so that code is already merged. It's already upstream, the dynamic volume provisioning.
Yeah, it has been a couple of cycles, actually a couple of releases that we have had.
Oh, really? So obviously we're not gonna be able to do that though, for sure.
Yeah,
so I was thinking the simple scenario that the part comes in. It's like a node affinity thing. Part comes in. I say I have a requirement for this PV. And he finds a node for that.
No, it's more than that. It's a lot more complex than that, actually. I mean, that case exists, and that's true if the volume is already bound to a node. So
yeah.
If it's already bound to a node, the problem is easy. You can just.
But even we don't even have that predicate as well.
Yeah, but that's not too hard to add. The harder problem is that dynamic volume bind.
Oh, that we're not gonna be able to do. I mean, obviously that's kind of so. We don't do that currently. So So I'm not worried about, but at least we want to be able to do basic PV thing though. I see. So add that. So essentially, the ephemeral is similar kind actually. Ephemeral storage and the PV storage static.
Right.
So that's something we need to do that actually. So hopefully that should bring down the failures in storage SIG, which we are noticing actually.
Sounds good. All right. Thanks. We are out of time, but if anybody else has any quick question, please go ahead.
I have a question related to 10 nodes by condition. What is the plan for that? Are we going to graduate it or?
So, well, actually, it wasn't. I haven't seen this issue with the scalability. If it is serious, we probably will not be able to graduate it to beta in 1.12. We are only several days away from the code freeze, so we may not be able to do that. But I will go and take a look. If this is something that can be quickly fixed, which I doubt, given that it seems like a major scalability issue.
Yeah, so I thought Klaus has mentioned something, saying that he's working on it.
Okay.
And I have generated some graphs where, like the call graphs, where most of the time we are spending on. I did not work further on that. So based on if you want to promote, I will continue working with him.
Yeah, it will be great. Actually, if you can help us and anybody else who is interested, if you guys can help us, it will be great to be able to promote it, because it has been a while that we really wanted to promote this to beta, and it's gonna resolve some. It's gonna at least make many things a little bit cleaner. So it'll be great if you can promote it, and if you guys have the time and you think we can reasonably get it to 1.12. Let's try.
Yeah, I think we do definitely want it to promote to beta in this release. So I will also take a look.
Okay, sounds good. I will also look. Thanks.
Just a quick question, Bobby. If you can send me the PR, remember the dynamic volume provisioning thing that went in 1.9. If you can just point me to the PR, that would be really great.
Okay, sure, I will.
Thank you.
Yeah, no problem. All right, is there any other question, comments? All right, thanks everybody. See you folks.
Thank you. Bye-bye.
Next week. Bye.
Thank you.
Bye.
Bye.